So this is a question from GATE 2018 from Chemical Engineering, question number 52. Hydrogenation of benzene is to be carried out using nickel with a density of 8910 kg per meter cube as catalyst, cast in the form of non-porous hollow cylinders as shown below. The reaction occurs on all the surfaces of the hollow cylinder. During an experiment, one such cylinder is suspended in the reactant stream. If the observed rate of reaction is 0.39 mole per meter square of the catalyst surface per minute, then the rate of the reaction in mole per kilogram of catalyst per minute is dash rounded off to 3 decimal places. So there is a question from kinetics part in chemical reaction engineering, and the reference NPTEL series can be found in module 1, lesson 9, basics of kinetics and contacting, chemical reaction engineering 1, homogeneous reactors by Professor K. Krishnaya, Department of Chemical Engineering, IIT Madras. So here in this question, they are trying to carry out a reaction using a catalyst by dipping this catalyst into the reaction stream. So here this catalyst is basically in the form of a hollow cylinder with the dimensions as given here. They have also said that the reaction happens on all the surfaces of the hollow cylinder, and the observed reaction rate is given as 0.39 mole per meter square of catalyst surface per minute. What we need to find here is the same rate of reaction for this process, but in terms of mole per kilogram of catalyst per minute. So basically what we are trying to do here is convert this reaction, which is given in mole per meter square catalyst per minute, to mole per kilogram of catalyst per minute. So let us see how we can do this. So here again the reaction rate is given as 0.39 mole per meter per minute, and we need it in terms of mole per kilogram catalyst per minute. So that means we need to somehow convert this meter square term into the kilogram term. So how we can do is, let us just write the units: meter square catalyst per minute. Now if we multiply this by kilogram catalyst and then divide it by meter square catalyst, then we'll get the new unit as mole per kilogram catalyst per minute, right? Because this meter square catalyst and meter square catalyst will get cancelled. So basically what we need to do here is we need to divide the reaction rate that we have been given by a term which has a unit kilogram of catalyst per meter square of catalyst. Or in other terms, we need to divide our reaction rate by weight per surface area of our catalyst. So if we divide our given rate by weight per area of the catalyst, we'll get the required reaction rate in terms of mole per kilogram catalyst per minute. So let us see how we can find this weight per area of the catalyst, and finally see how we can find the final answer. So to find weight per area of the catalyst, we need two things, which is obviously the weight of catalyst used and the surface area of the catalyst used. Let us start with the weight of catalyst used. So weight of catalyst used W will be equal to density into volume of catalyst. So here they have given that the density of the catalyst is 8910 kilogram per meter cube. And the catalyst is a hollow sphere and the dimensions are also given. So we can use these dimensions and the fact that the catalyst is a hollow sphere, and we can find the volume of the catalyst. So volume of the catalyst V will be the formula for volume of a cylinder will be pi d square by 4 into h. So we'll just use this formula to find the volume of the catalyst. So this weight will be 8910 into volume of the catalyst. So this is a hollow sphere. The outer diameters are given as 25 and the inner diameters are given as 20. The height is also given as 25. So volume of a hollow sphere will be pi into h into d square by 4 minus small d square by 4, where this capital D is 25 mm and small d is 20 mm and the height h is 25 mm. So weight of the catalyst W will be 8910 into pi into 25 mm, which is 0.025 meter, by 4 into d square. So 25 mm square, that will be 0.025 square minus 20 mm square, which will be 0.02 square. So if we do the math here, we'll get the final answer for weight in terms of pi as W is equal to 0.01253 into pi kgs. Now let us move on to the area of the catalyst. So area of the catalyst. So again, this is a hollow sphere. So here there are four areas here. One is the outer area, then there will be an inner area, and then there will be two more areas, which are the areas at the top ring and the bottom ring. So area of the catalyst will basically be outer surface area plus inner surface area plus top ring area plus bottom area. So area of catalyst A will be outer surface area. For a cylinder, the area can be calculated as pi d into h. This will be the area of a cylinder. So for outer surface area, it will be pi into capital D into h plus inner surface area, which will be pi into small d into h, plus top area and bottom area will basically be the same. So we can just write it as 2 into top area, which will be the area which is in the shape of the ring. So that will be pi into d square minus small d square by 4. So here capital D is basically 25 mm, small d is 20 mm, and h is 25 mm. So this will be pi into d, which is 25 mm or 0.025 meter, into height, which is again 0.025 meter, plus pi into d small d, which is 0.02 meter, into height, which is 0.025 meter, plus 2 into pi d square, that is 0.025 the whole square, minus small d square, which is 0.02 the whole square, by 4. So if we do the math here, we'll get an area in terms of pi as 0.001235 into pi. So now we have W, we have A, W as 0.01253 kg and A as, sorry, okay. So now we have W is equal to 0.01253 into pi kg and A, which is 0.001235 into pi meter square. So W by A will basically be the ratio of this, and if we divide these two, the pi and pi will get cancelled, and if we do the math here, we'll get W by A is equal to 10.125 kilogram per meter square. So now our reaction rate in terms of kilogram per catalyst. So let us denote it as minus RA W. This will be the given reaction rate by W by A of catalyst. So this will be 0.39 by 10.125 kilogram per meter square of catalyst. And if we do the math here, we'll get the final answer as 0.0385. And since we need to approximate it in 3 decimal points, it will be approximately 0.039, and the unit will be mole per kilogram catalyst per minute. The right answer will vary between 0.034 to 0.043.